An important application of predictive analytics at financial institutions is to predict the approval of loans. Generally, the first step after a customer applies for a loan is to validate the eligibility of the customer for the loan. This involves the lender looking at various background information about the applicant and deciding whether the bank should grant the loan. Parameters like credit score, loan amount, lifestyle, income, and education are some deciding factors in getting the loan approved. The objective of this project is to predict the loan approval status of a new applicant using Bayesian logistic regression. This is a binary classification problem in which we need to classify whether a new loan will be approved or not. The dataset used for the analysis has been taken from Kaggle. It contains 614 records containing information on past loans. It has 12 variables containing information on gender, marital status, number of dependents, education level, whether the applicant is self-employed, income of the applicant and co-applicant, loan amount and its term, credit history availability, property area. The dependent variable here is the loan approval status. This is coded as 1 for loan approved and 0 for loan rejected. The rest are independent variables that are used for prediction. Except for applicant and co-applicant income and the loan amount, the rest are categorical variables. We split the data set into 70% train and 30% test for the analysis. We then pre-process the data. We use mode imputation for handling NAs of categorical variables and mean imputation for numeric variables. We then look at the scatter plots for each of the independent variables with the dependent variable. We don't observe any pattern for gender versus loan status, so this is expected to not be very significant in the model. Similarly, we don't observe any trends for marital status, number of dependents, education, self-employed status, loan amount term, credit history and property area as we observe zeros and ones across the board. There are some outliers in applicant and co-applicant income where extremely high incomes are associated with loan not getting approved. There are a few outliers in loan amount as well, but we don't really see a significant pattern there. The mathematical model and the JAX model diagram are as shown here. Since we have a binary variable, we have a Bernoulli likelihood where theta is the success probability. The model is put on this parameter theta. We use the logistic link function to link the linear model containing the independent variables to the success probability. We then compare this to the threshold of 0.5 and make predictions. Beta 0 is the intercept. Each of the regression coefficients beta 1 to beta 11 indicate how much a unit change of the predictors increases the log odds of outcome 1, that is of the loan getting approved. In the diagram, mu is the success probability for each record in the data. This is equal to the logistic model. As the beta parameters are continuous and defined from -infinity to +infinity, normal priors are used for each of the regression coefficients. We standardize the independent variables to improve mixing and reduce order correlation during MCMC procedure. We do not standardize y values as it is binary. We then do a back transformation to get the beta values. As we do not have any expert information, we use non-informative priors for each of the beta coefficients. As the mean is 0 and standard deviation 1 when we do the standardization, we use a high variance of 4 for non-informative prior. We will also use a guessing parameter so that the model can use a random guess when it is impacted by outliers. The settings of the MCMC chains are as shown here. The diagnostic plots generated are as shown here. In terms of representativeness, we can see a good mixing of chain in all the plots as there is no specific trend. All plots have a shrink factor less than 1.1. Looking at the density plot, we can say that the PDF chains are overlapping to a good extent. Also, the upper and lower limits of HDI intervals are overlapping or are very close. In terms of accuracy, all plots have a low autocorrelation which is almost 0. They all have a high SS value of around 3500 and have a very low MCSE. The posterior distributions are as shown here. Looking at the summary information, beta 2 and beta 10 are significant. The odds of getting a loan approved is 11 times higher for each level increase in marital status. When there is a credit history availability, the probability of getting a loan approved increases by 3800 times. This is as per expectation. We can also see how significant credit history is looking at the posterior distribution as it has a high mode and 100% of values are greater than 0. From the confusion matrix, we can see that the accuracy of the model is 77%. This run took about 10 minutes to finish. As the next step, we can try to improve this further by changing the MCMC settings and increasing the number of steps in chains.